Very good morning to you all. Let us start our today's session with a new topic. The topic is characteristic velocity and thrust coefficient. So this also already we discussed. This already discussed in our rocket performance parameters. And I'm going to give you a deep introduction about this, deep discussion about this topic as well as some numerical related to rocket engine performance. So already we had the characteristic velocity, that is C star, already we discussed. That is the case. M dot equal to we can say Vj by C star, or C star Cf equal to Vj by C star. So where Cj or Vj is the jet velocity and C star is the characteristic velocity, and Cf is the thrust coefficient. Here we are going to relate the characteristic velocity and that thrust coefficient. Here the thrust coefficient is nothing but Cf, and the characteristic velocity is defined by the symbol C star. So already we had one velocity known as exhaust jet velocity or effective jet velocity, that is known as Vj. So if you go for V equivalent, that will be considering pressure exceed and pressure ambient cases, whereas we are equal in neglecting case, it will be effective exhaust velocity Vj. So that thing is, we are proving, we are having the relation of C star in terms of Vj and Cf. So in order to define the thrust coefficient, in order to derive the thrust coefficient, we had a basic expression F is equal to m dot into Vj plus P minus Pa into Ae. So here P minus Pa in Pa is as it is. Here I am substituting m dot into Vj. So Vj formula last class we discussed in Nozzle expense ratio. That is there in the second terminology, that is in the root of the root term, root under the root 2 gamma RTC by gamma minus 1 into 1 minus P by PC per gamma minus 1 by gamma, that is nothing but Vj. So root of 2 gamma RTC by gamma minus 1 into 1 minus P by PC power gamma minus 1 by gamma is the Vj velocity. This Vj we could able to derive from the general thermodynamics principle, steady flow energy equation, H naught equal to He plus of V squared, T naught equal to E plus of V squared by Cp. From that we have Cp where in terms of gamma R by gamma minus 1 as well. Yeah, substituting in terms of all these relations of basic thermodynamics that you studied in your thermodynamics as well as in your breathing propulsion as well as in your aerodynamics 2 also. So based on that, we had the general expression Vj is there in this second under the root that term that is called as Vj. The second one more term is m dot. So m dot, as you know, rho a v. As I mentioned earlier, rho into a into v. So here I correspond to the, as you know, mass rate remain constant. So go for the choking condition, m dot Mach number equal to 1 condition. So there rho is equal, already we discussed, rho is equal to, what is the relation between pressure, rho, density and pressure? What's the relation between density and pressure, P and rho, in terms of temperature? Anyone?
So P equal to rho RT.
Yeah, same thing. Fine, same thing. P is equal to rho RT. So using that relation, rho in place of rho, I put a P by RTC. Okay, that is on the first step. That is there in the first component. I have added with the m dot. That only I'm explaining. So P by RTC, B by RTC. That is for the throat section. Similarly, area of throat is 80, no change. So 80 is as it is. So another one terminology we have is velocity. Velocity correspond to that of the what I call the throat. So that Vt is given by the relation in terms of Mach number equal to 1 correspond. So just now we told you Vj in terms of the Vj is there. It is for Mach any exceed Mach number. Thereby we have the pressure ratios. If you go for the Mach number equal to 1 case, thereby pressure ratio and temperature ratio in terms of Mach number, there we have a relation that is nothing but T naught by T is equal to 1 plus gamma minus 1 by 2 into m square. That also steady flow energy equation derived one that is should be studied in your thermodynamics and propulsion, air breathing propulsion. So T naught by T is equal to 1 plus gamma minus 1 by 2 m square. So m equal to 1 if it is throat. So me is there, we can go for the Vj. So Vj there we have pressure ratio in terms of temperature ratio, isotope relation, that's there in the that is there in the second component. So if you go for the throat condition, you would substitute in terms of T naught by T is equal to 1 plus gamma minus 2 m square. You would substitute Mac equal to 1. So go for Mac equal to 1, equating, and as well you would relate what is the relation continuity equation m dot equal to rho e a e is equal to rho t a t. So using the relation rho e a e is equal to rho t a t, and in the, using three component m dot equal to rho e a e into rho t a t, that throat section and exit section equality, then substitute p rho in terms of p by rt, then go for using the Mach number equal to 1 case for the throat condition, that you would substitute at the end. You will arrive with an expression in terms of m dot equal to root of gamma into 2 by gamma plus 1 into gamma plus 1 by 2 into gamma minus 1 into by what I call. Then you can go for substituting for area throat and as well as pressure at throat as PT by RTC, rho T is equal to PT by RTC, and area throat as AT. The remaining term, how you arrived with that other term is nothing but by equating rho E AE is equal to rho E AE V is equal to rho T AT VT. So using the relation, you can have the expression. Already we have A by 8 equal to what? That already derived in the last class. So substituting the A by 8 relation here, and then go for the rho, density, everything. Finally, you will arrive with this m dot equal to root of gamma into 2 by gamma plus 1 the whole power, gamma plus 1 by 2 into gamma minus 1 into PCAD by root of RTC. So that will be given to you as assignment. So since you have to study over all this in thermodynamics, so just arrive with this this first steps by using basic thermodynamics, and this should be your assignment. You have to submit the assignment. Later on, I will solve it, and I have the solved content. I will solve with the step-by-step procedure once you submitted the assignment. So that time I will recall the topic again, and I will tell you how you are to do this expression. So as far as the case, since you had this topic in your thermodynamics and everything propulsion and aerodynamics 1, so now I am giving I directly return the expression what you already learned from your basic subjects, thermodynamics and everything propulsion aerodynamics subjects. So it is given to you as an assignment. So already assignment posted in the class group and that Google Classroom. So try to solve step-by-step procedure using the basic thermodynamics. I just want to test your knowledge in your thermodynamics. So later on, I will show you the step-by-step procedure of this derived expression. So using that, m dot can be substituted and Vj can be substituted, and you can go for P minus PAAE. So next up, what you did it, I took a PCAT common as a common terminology outside, then keep other thing as it remains as it is. So then rearrange it. That is the next step. Second step is PCAT taken outside. Then go for, if you divide PE by PCAT and PA by PCAT. So like that. So AE by AT will be coming outside that case. So like that, I took commonly for entire total derived that component PCAT taken out. Then remaining will be inside. So later on, then next step will be, as I told you, CF can be found. CF is nothing but F by PCAT. So thrust coefficient is defined as thrust to the force term PCAT. That also already discussed in the rocket performance parameter that class. So use that formula, that is F by PCAT is equal to CF. So that's it. So then you can go for F by PCAT, then becomes CF. That is on the next step. So remaining will be root of gamma into 2 by gamma plus 1 into the whole power gamma plus 1 by root of RTC 2 by gamma minus 1 plus 1 by root of RTC root of 2 gamma RTC by gamma minus 1 into 1 minus P by PC per gamma minus 1 by gamma plus P by PC minus PA by PC into A by AT. So this is the expression for thrust coefficient. So how you arrive that is, you have to find m dot from the continuity equation in terms of equating exit and throat condition as m dot is equal to rho E AE is equal to rho T AT. So where rho E AE is exit density and exit area. Similarly, rho T AT is throat density and throat area. So equating, then we can go for substituting what I call like P pro is equal in terms of P by RT, and then similarly go for substituting Vj expression that you had in your the energy equation, steady flow energy equation, final relation in terms of Vj. Then as well you would relate throat condition of the what I call the ratio of area exit to the throat area. That can be substituted here. At the end, you will be getting taking common term PCAT outside. Then we have one simplified form. Then afterwards, so what is objective is, as you know, CF is nothing but F by PCAT. So in order to get CF, that is F by PCAT. So that's why we are taking PCAT outside. So once the PCAT come out, then F is already there. So F by PCAT nothing but CF. So CF can be, the expression can be given in this way. This is called as this is the thrust coefficient equation. Again we have two coefficient. One is the ideal thrust coefficient, another one is actual thrust coefficient. Idealization, there is nothing but P exit equal to PA. That means the P, if you're substituting P x equal to P in that expression, you'll be having one equation that is called as ideal thrust coefficient. So if you are keeping without substituting P is equal to PA case, or P is not equal to PA at any case, then it is called as actual thrust coefficient. Similarly, we have ideal characteristic velocity, actual characteristic velocity. So in this case, correspond to the CF. The C star will be ideal characteristic velocity and actual characteristic velocity. So this is the general expression for the thrust coefficient and characteristic velocity. So if you want to go for this, what I call the thrust coefficient equation, you should have the idea about the expression for Vj and thrust equation and the expression for the mass flow rate m dot. Okay, that is there in the, that is the way of deriving the expression for this what I call it, characteristic velocity and thrust coefficients. So for this, the thing is very simple. For this, we need to have the basic idea about the thermodynamics, steady flow energy equation, continuity equation, and what I call. So that's the thing. You see, what I told you, like m dot equal to rho E VE, that is equal to rho T VT. That only can be used for to get this m dot. So that is here. You see that the expression. So I am giving how you arrived at this. I just want to show you that thing again here. So how you arrived at this m dot expression in terms of PCAT by C star and all. That is also a kind of C star. So here you see that m dot value expression arrived root of gamma 2 by gamma plus 1 gamma plus 1 by 2 gamma minus PCAT by root of this. So I am saying, I am going to explain how we obtain that m dot. So anyhow, you should have all this thing in your previous study. I am repeating again, as in the case of, since it is applicable to rocket system. So this is a general expression for the isentropic flow through the nozzle. So that is, this is the expression nothing but isentropic flow through the nozzle. Wherever we are using nozzle, we can use it. So since it is for a rocket engine also we are using nozzle, that's why we are recalling the topic again. So again, I am explaining to you for your easy understanding. So first up is nothing but m dot equal to rho T VT, that I told you already. That is nothing but, so you are substituting what I did is, next up I simply divide and multiply by rho C. So rho C into AT root of RTC. This is the other way of doing. So we can go with PT also, otherwise you could at least use it. So then it becomes PT by RTC. Then already we have RTC is a PC already cross multiply. Again RTC also multiply divide. For simplification only we are doing. Then AT and then root of RTC. So again PCPC is already there. Then we have the relation. What is the relation? Pressure PC by PT relation, or pressure P naught by PT. Some book they are using P naught, some book they are using PC. So PC is chamber, P naught is stagnation pressure correspond to the chamber. So you can use PC or P naught, both can be. PC is for the chamber pressure, P naught for the stagnation condition. Since it exists, that chamber exists in stagnation, so P naught is equal to PC. So you can use PC or P naught. So in aerodynamics and all, they are using P naught. So since we are using chamber in the propulsion, that's why we are using PC. That's the difference. So here you can use P naught or PC, whatever you can. If it is convenient, you can use it. But I'm using only PC. So as I already told you, PT by PC is nothing but pressure ratio of throat to the chamber. Similarly, temperature ratio of TC by TT, that is chamber to throat. So other thing as it is, don't touch PCAT root of RTC, don't touch. Similarly, Other than that, you can use it. So again, already here we have one RTC, here we have one RTC, then there we have one root of gamma RTC. So that gamma can be taken outside, root gamma as it is, keep it here. Then already we have one root RTC, here we have two or three, sorry, there we have one RTC, then root RTC, then again two RTC square. So if you are dividing and casing, cancelling all this term, at the end you'll be getting divided by root of RTC or 1 by root of RTC. So that's in mathematics. Already gamma only we took it outside. Then root gamma is there. Then obviously you see here also we have one TC. Then already there we have T is there. If you take it inside, so that TC becomes root TC. So that way you can arrange it, rearrange it. So the PT by PC as it is, and TC by TT as it is, and then PC80 by in the RTC terms become root RTC. That is here 1 by root RTC. Similarly, root gamma is root gamma only, no change. So inside already we have one TT. So if you take this one TC inside, that is only for simplification. You can see the third step. So we directly substitute in terms of gamma and all in place of temperature ratio, pressure ratio. So for that purpose, we are just rearranging some dividing and multiplying and dividing by sometimes times, then taking the cancelling sometimes and then rearrange. So that way you got to do the next second step. The third step, so already mentioned, you have pressure ratio correspond to Mach equal to 1, temperature ratio correspond to Mach equal to 1 at the throat. That we will be getting the formula that is given in this 2 by gamma plus 1. So 2 by gamma plus 1 power gamma by gamma minus 1 for it is nothing but pressure ratio P naught by PC at throat. Second one is TC by T naught TT. So if it is reciprocal, that's why minus 1 came. So otherwise T naught by TC, so TT by T naught equal to nothing but 2 by gamma plus 1. So that's why it's nothing but 2 by gamma plus 1 power inverse. So that is there. So the other thing is no change. PC80 by root RTC, don't touch it. Is as it is. Root gamma also as it is. Again, next one we have one again the temperature ratio at the throat. So that is TT by TC. So TT by TC is nothing but 2 by gamma plus 1. That's all. So that are all nothing but relating isentropic relation in nozzle throat. So isentropic relation nozzle throat is nothing but P naught by P naught by P at any point at gamma by gamma minus 1 is equal to T naught by T power T naught by T, like that. So using that kind of relation, Eisen relations, you got to be careful with the gamma minus 1 and all. Either it is, if we go for reciprocal, it will be, if it is P naught by PC, so we have one component. If we have PC by P naught, we have some other. PT by P naught, we have some component. So go and check thermodynamics isentropic flow through nozzle again one more time. So using that only, we are grouping all 2 by gamma plus 1 together and keep other term as it is, without any change. Thereby we have root gamma into 2 by gamma plus 1 into gamma plus 1 by 2 into gamma minus 1 into PC80 by root RTC. That only we substituted in your thrust coefficient equation in place of m dot. So m dot, we just explained how you go to arrive with the m dot. So again, I have another one simplification, simplified form. I using one term called as capital gamma. So in that last expression, you see one the gamma, that is nothing but capital gamma. So the capital gamma is nothing but wherever we have the gamma term, and together root gamma into 2 by gamma plus 1 into gamma plus 1 by 2 into gamma minus 1. All the gamma term together is termed as capital gamma. That is a simplified form. So if you want to solve numerical, first calculate capital gamma, that is nothing but root gamma 2 by gamma plus 1 into gamma plus 1 by 2 into gamma minus 1. That is capital gamma. Next PC80 by root RTC. That's all. So that is also equal to m dot equal to PC80 by C star, where C star is characteristic velocity. So that only expression for the characteristic velocity. So the thing is very simple. You should have the basic thermodynamics knowledge. You should have the isentropic flow through nozzle relation, and you should have the idea about the if Mach equal to 1, what will be the relation? If Mach equal to any Mach, what will be the relation? So you can have a stagnation and static relation. So stagnation correspond to chamber, static correspond to any state, maybe a nozzle exit or nozzle entry or diffuser exit, whatever maybe. But for us case, it is a nozzle. So you have to go for first start with the expression T naught by T equal to what? That is very simple. I again repeating the formula. T naught by T is equal to 1 plus gamma minus 1 by 2 into m square. That is one formula. Okay. So use that to come a Mach number. If you substitute Mach, it becomes E. That will be in one formula. Similarly, you can have one more formula. T naught equal to T plus half V squared by Cp. Okay, from there only we obtain this Mach number relation. Substituting for Cp gamma r by gamma minus 1 and gamma RT becomes area, sonic sound velocity A. So if you go for relating, it becomes Mach m square. So T naught by T is equal to 1 plus m, 1 plus gamma minus 1 by 2 into m square. That is one expression. T naught is equal to T plus of V squared by Cp. V square, V may be any velocity, exit velocity or jet velocity or exit Ve or Vj or Va. That is the V. So that's correspond to, that relates isentropic, energy equation correspond to the stagnation and static property of temperature. So if you go for the isolation, pressure ratio in terms of temperature ratio, power of gamma and gamma minus 1, that is the second expression. So there you would use two equation. One is the steady flow energy equation. Other one is the what I call Eisen relation. So use these two relation base and do some simplified steps, multiply and divide and all for grouping or arranging to get some formula related to temperature ratio and pressure ratio. Then substitute, you will be able to get area expansion ratio, area by relation, m dot relation, and one more relation is CF relation. So if it is a physical examination, you are to derive the expression for your examination. So be ready for that also. Like that, this is the expression for the mass flow rate of the flow through a nozzle. Exit area to a throat area, that is known as nozzle expansion ratio relation of the nozzle. So for information, both the last derived formula is available in your gas table. So both the formulas are available in gas table also. So we can use it. There they may use PC in place of PC. They may use P naught. That may be the changes they might have. So PC, as I mentioned earlier, PC equal to P naught. Both are same. Since in propulsion it is chamber, that's why I'm using C. But in aerodynamics, they used to use it as P naught. So lot of various methods to derive this expression. This is a one way of doing. So this is comparatively similar to other expression. Only thing is relating rho T ATV, rho EAV or order maybe, then go for substituting P by RT, then multiply and divided by PC and multiply divided by RTC. At the end, you will be getting some expression in terms of pressure ratio, temperature ratio for throat and chamber. And the remaining as it is, no need to change it. Then substitute for that for Mach equal to 1 case, then will be arriving, then grouping all gamma time together one area, that is called as capital gamma. The remaining as it is. So at the end you will be having m dot equal to capital gamma into PCAT by root RTC, that is also equal to PCAT by C star, where C star is parity velocity. So next what I already discussed is thrust coefficient. That thrust coefficient of the body F by PCAT. There you would use thrust equation in terms of P and PA equivalent cases. Then go for substituting again using this m dot in that expression, Bj in that expression, and divided by whole by PCAT. So at the end you will be getting F in terms of PC. Sorry, take common term PCAT outside. So that rearrangements. So that will give F by PCAT equal to CF. So that is the another expression, thrust coefficient expression for the what I call a rocket system. So what you want to do it, you better to go and start writing the assignment, which is all three derivation: parity velocity, thrust coefficient, and what I call mass rate. Then only you will come to know how you derived and how you substituted all these things. And I am again repeating that is based on basic thermodynamics of isentropic flow through a nozzle, steady flow energy equation, two relations that is used, that was used for solving this or deriving this or obtaining this expression. So this expression also should not be new to you. This could be already studied in your air breathing propulsion also, since we are using nozzles in your jet engine also. So this is applicable for any general nozzle applicable system of working component. Okay, so if you have any doubt, you can ask now also. better to write it as an assignment so that you may get some more doubts how you arrived with and all. So that way it will be useful for you. So for the time now, if you have any doubt on this relation, you can ask. Feel free to ask question, sorry, doubt, you clarify your doubts. Don't be simply idle and be having doubts in later on. Any doubts? Are you there? Yes or no?
Yes, sir.
Yeah, the thing is, I'm supposed to ask a question in between. Since you chose the old topic, you should have studied in your previous studies. But since you are facing some problem, you were told like we didn't study and all. So that's why I didn't interfere in between. But normally I used to derive the expression with interacting with the people and get your input and substitution. That was the procedure. But I don't know what happened. But I think now aerodynamics also they are taking. I think Dr. Bharadwaj is handling the subject. He might have discussing the same topic to you. Am I right?
Yes.
Is it right? Yeah. So there may be some more different method they may use, but idea concept is same. Both the concepts are same. So I say again repeating, they were using with respect to airflow. We are discussing with respect to gas flow. So they are dealing with any reservoir to the nozzle, like kind of case to a duct or something like that, duct variable duct, something like that. But our case, chamber to nozzle. So that's why I keep on repeating. Stagnation correspond to chamber. PC, P naught. Other area, it is any location, maybe throat or maybe exit, it is P only. So P is P, T is T. It may be PE or it may be T is what I call PA. Similarly, it may be a TE or it can be a TT or it can be a TC, whatever may be. So like that, the stagnation only correspond to chamber. So from the reservoir, that will be always stagnation. So we are relating stagnation and static to get the Mach number relation as well as velocity relations. Using that and in terms of gamma, R, and T, as well as you are using density in terms of pressure, and then substituting all these things together, you will come to know get these three expressions. Nozzle expansion ratio A by A star. Another one is mass flow rate through the nozzle. Duct, you can call it as duct also. Is a common duct. You can timing as duct also some cases. The third one is thrust coefficient for our case rocket system. So that will not be there in your this C star and CF may not be there in that case, but area expression ratio and mass flow rate will be there in your aerodynamics. C star and CF is our performance parameters rocket system. So that is the additional topic you want to do it by substituting the same m dot and same that relation of kinetic equation and the other thing. You can use it and get the relation for this character velocity and thrust coefficient. So it's better to go and take on paper and start right to solve this expression for area expansion ratio first one, mass flow rate second one, third one thrust coefficient. So that you might have some doubts in between. You could be able to clear that out also. You feel free to ask me, call me and ask it out if you have any. Okay, later on that time. What is it fine, Sanjay? I think Sanjay only always interacting, so I got to ask him only. I think so. Sanjay, is it fine?
Yes, sir.
Okay, fine. Anybody else have any doubts? Any kind of getting some inputs? You can ask.
No doubt, sir.
No doubt, fine. Anyway, just as a basic one, just only arranging, substituting, multiplying, dividing, and to get some form of substitution like that only. So that is a way of doing the derivation. Derivation is always like that only. So once you derive on your own only, it will be useful for you. If you simply see on the screen, I'm only explaining, it look like you know everything, I know everything like that. But at the end, later on, once you go on substituting and arranging and all, that time it will be a problem. So again, I want to tell you for information, the same, not the equation C star, other formula is already available. Mass flow rate, exponential ratio, all the thing available in your gas table bus page. You can compare it and this and that. So there may be some notation may differ, some arrangement may differ, but idea is same, matter is same. Okay. So I think within that we can stop this session, I think. I'm right. You may have next hour also, I think. Are you free next hour or you have class?